Okay, so this is part C in question 14. I have this plane. I know the equation of the plane is going to be x minus 2y plus z. X minus 2y plus z equals 0. And I've got to show that this point, point C, lies on the plane. Well, if I sub the x-coordinate where x is and the y-coordinate where y is and the z-coordinate where z is, I should get an answer of 0. So x minus 2y plus z equals 0. If point C is on, then minus 2 times 2 plus 6 should equal 0. Minus 2 minus 4 plus 6 equals 0. 0 does equal 0. Therefore, C is on the plane. X minus 2y plus z equals 0. So that's the first bit. And find the point of intersection of the lines OB and AC. OB and AC, find the intersection of those lines. Okay, the second part of the question is to find the intersection point of lines OB and AC. So OB, AC. So I'm going to call OB line 1 and AC line 2. And OB being line 1, you can have a rule of R1, which will be some point on the line plus T times the direction of the line. And I'm going to use the fact that the origin is on the line OB, so that will be 0 on the I plus 0 on the J plus 0 on the K, and the direction that it goes on is this direction, which is J plus 2K, which means that R1 equals T in the J plus 2T in the K. So I've created an equation for line 1. If I do the same thing for line 2, R2 will be some point that's on R2 plus S times the direction of R2. Now, I can pick either of these points. I'm going to pick this as being the point on R2, so I plus J plus K, and then the direction, if I go from here to there, will be -2 minus 1, that's minus 3i. 6 minus 1 is J, and in the K it's going to be 6 minus 1 or 5, which means R2 is in the I plus in the J plus in the K, 1 minus 3s, 1 plus s, and 1 plus 5s. And since I'm looking for the intersection point of these two lines, if I equate the I components together, then 1 minus 3s equals nothing because there is no I, which means that minus 3s equals 1, s equals 1/3, which means this is 4/3, which means that T equals 4/3. Now, if that is the case, then 2 times 4/3 is 8/3, and 1 plus 5s, which is 1/3, is 1 plus 5/3, which is 3/3 plus 5/3, which is 8/3, which is correct. So those two values of s and t are correct. I can find the coordinate of the intersection point by subbing in either t equals 4/3 or s equals 1/3 into them. Doesn't matter which one you pick because you get the same equation, if you get the same point in both. Therefore, R1, when t equals 4/3, is going to be 4/3 in the J plus 8/3 in the K, so 0, 4/3, 8/3 is the position of the intersection point. I'm going to call it point M, the point where those two lines intersect. Just to show you it doesn't matter which one to pick, if I choose 1/3 here, I'm going to have 1 minus 3 lots of 1/3, which is going to be 0, correct. I'm going to have 1 plus 1/3, which is 4/3, correct. And I'm going to have 8/3, correct. Same answer. So that is the position where the lines intersect.